Hello and welcome back to my non-existent YouTube channel. Today we're going to do some math with Miss Davis. And we are focusing on substitution to solve systems of equations. Some of these, like the first two that we did in our warm-up, are going to have one solution. And others could possibly have no solution, meaning they are parallel lines or infinite solutions. So, without further ado, let's get into the video. Number 3, we have x minus 2y equals -1 and 3y equals x plus 4. So these are a little bit different than the other two because we don't have something that is very clearly isolated. I would say the easiest one to get by itself would be the first one. So I'm going to do a little bit of rearranging so that we do have x by itself. So I will add 2y to both sides. And now I'll have x equals 2y minus 1. At this point, I can substitute into x in the second equation. So now I will have 3y equals 2y minus 1 plus 4. So here I'm going to move my 2y over and combine like terms. It's all going to happen pretty quickly in one step. So that will be gone. I'll be left with y on this side, and -1 plus 4 on this side is 3. So now that I have my y coordinate, I can find my x coordinate. So I can plug it into either of these. I'll probably just use the second one. So I had 3y equals x plus 4, so now that'll become 3 times 3 equals x plus 4, which means 9 is equal to x plus 4. And my x coordinate is 5. So now that I have both of them, I can put my answer coordinate together. These lines will intersect at 5, 3. All right, let's do another one together. Number 4 is similar to number 3. If I want to use substitution here, both of my variables in the second line have coefficients, so that would be harder to isolate. Whereas in the first line, I do have c by itself, so I could just move this over. So that's what I'm going to do. So I'm going to move the 4d over to isolate c. So I'll get c equals 4d plus 1. And now I can take this and substitute it in here for c. So this will become 2 times 4d plus 1 minus 8d equals 2. So now we're going to distribute, combine like terms, and solve. So this will become 8d plus 2 minus 8d equals 2. Oh, we've got something interesting happening here. So when we combine these, we're going to get nothing, no d, and 2 equals 2. So in this case, we are left with a true equation that will always be true. So this one is infinite solutions. Okay, moving along to number 5. Same thing, I'll check to see where my coefficients are. So since both of these have coefficients, whereas x is by itself, I'm going to isolate the x for substitution, since we're solving with substitution today. So I'll subtract 2y on both sides, and I will get x equals -2y. So now this is ready to plug in here for x, so this is going to get substituted. So 3 times -2y plus 4y equals 4. This will multiply to make -6y. And now I can combine like terms. I get -2y equals 4, divide by -2, and I get y equals -2. Now that I have my y coordinate, I can plug it in to find my x coordinate. Honestly, this isolated one is probably the easiest one to plug this into, although you could use your original equations. But if y equals -2 and x equals -2 times y, that means x equals -2 times -2, which means x equals 4. So the answer coordinate, my one solution will be 4, -2, x comma y. I really should have given you guys more room on this sheet, huh? Okay, number 6, last one. Before we get into number 7, we have coefficient for x, coefficient for y, x by itself, 14 in front of y. So I'm going to isolate this x by subtracting 14y on both sides. And I get x equals -14y plus 84. So I will substitute that in here for x. And distribute. So this becomes -28y plus, I'm using a calculator here because I don't want to mess this up for you, 168 minus 7y equals -7. So when I combine these two, I'm going to get -35y plus 168 equals -7. Move the 168 over. Which will give me -175. This is a long one. And then I divide by -35 on both sides. And I get y equals 5. Whew. Almost done. Now I can plug this back in here to get what x equals. So I'm gonna just like make myself some room over here. So x plus 14y equals 84. X plus 14 times 5 equals 84. 14 times 5 is 70. So x plus 70 is 84. Subtract, and we get x equals 14. So this final answer is 14.5 for where these points, or where these lines intersect. All right. I know that was a lot, so I will leave number 7 aside, but I wanted to make sure that you could see me do these problems over and over because technology has been failing us. Bye. Oh, I hit the camera. Bye.